Hello again, folks. Welcome to the Land Tamer stream. We're doing more EIGRP filtering tonight. Hopefully do 3 labs. And tonight, I've had a chance to actually do a good bit of research beforehand, so I won't have to do a lot of that on stream. We should be able to just get right into them. There is a point later where I'm going to get into some of the differences in documentation that I found, or some things I found out on the Cisco documentation in regards to the distance command, and I'll get into that a little later and some other things we've learned. But first, this lab is EIGRP filtering using extended ACLs. Yesterday we did, I think, standard ACLs, and the requirements in this lab are: first, disable the link to router 4 on router 5. So we're going to, because router 5 has 2 links to router 4, essentially, and this is all about filtering to router 5. So we're going to shut down that link, which you can see here, Jazz 0145, and we're going to do some filtering going this way. Actually, I think it's inbound. No, it's outbound. Yeah, because the requirements here are, we want to do extended ACL filter for the following. This gets a little tricky. So router 4 and router 6's loopback 0 should be coming from router 2. So we want to see basically these. This is router 4's loopback 0. This is router 6's. We want to see those only from router 2. We don't want to get them from routers 1 through 4, because on this link, and we're talking about the tunnel link, we've got 1, 2, 3, 4 routers here. So what we're going to have to do is put a filter on incoming routes, and we only want to see these routes come from router 2 in this case. We've got another set of routes that we want to see from router 3, and another set that we want to see from router 1 only. So yeah, router 1 and 2's loopback 0 should only come from router 3. That's these two. Router 7 and 9's should only come from router 1. And no other routes should be affected. That's important, right? So my first approach to preparing for this lab was to say, okay, obviously we'll want to use the most efficient access list that we can. So let's see if we can summarize these. And I started out doing this, doing our typical summarization exercise. Whenever you want to summarize, right, you want to find where you can draw the line. Where's the closest to the left, to the right, depending on how you're looking at it, where you can draw the line. And can I do that? Can I summarize, for example, router 4 and router 6's loopbacks? Can I summarize those and not affect other routes? And initially I went through this and I thought, yeah, I can certainly create a summary route. In fact, I could say, let's say, now this is for an access list, right? So we're going to use a wildcard mask. I could say, well, I can draw the line here, which would be a /22. And that's the closest I can get really to summarizing these routes. That's the most specific common prefix I can do. So I can do 150.1.4.0, 0.0.22 would be 252.255, right? So I'm going to ignore, with the wildcard mask, I'm reading from the right. Which host bits can I ignore? So I'm going to ignore these, and I'm just going to look at the bits here up to here. The problem with that is, and I did that for all these, as you can see, I wrote these out. I found for 7 and 9, there's no way to summarize these into a /22 block. So I thought, well, the next I could do a /20, well, actually a /20, right? But there was no way that was gonna, and then I figured out, well, really none of these is gonna create a summary that will allow me to not affect other routes. Because, for example, on this one, I've got a 150.1.5.5. If I use a deny statement with this access list, it's going to block 5.5 as well. And I can't do that. So essentially, you know, I wish I would have recognized this earlier on before I did all this work. But I'm going to have to use host routes. There's no other, which is going to be a lot of access list statements for an extended access list. So I'm going to have to create access lists for every one of these loopbacks. Not only that, but I'm going to have to say, I'm going to have to deny them for multiple gateways. So if I create an access list extended 101, here's router 4's loopback, here's router 6's loopback. So I have to deny that for router 1 because it says I want those from router 2. So I have to deny them from router 1. I have to copy paste those statements, deny them from router 3, deny them from router 4. And so on and so forth, all the way down. So yeah, that's a lot of access list statements. And then at the end, I have to say permit any. I don't know any other way to do that efficiently. I could not find any in my research anyway. We're going to find out in a minute, A, if this works, and then B, if we look at the key here, if maybe I missed something, right? Maybe there is a better way to do this. I couldn't find one. So these are the access lists. This is the extended access list 101 that I came up with. And then obviously what we're going to do is, I think I have the direction wrong here. Because it says, let me double check. Okay, it says traffic destined to these loopbacks should be sent to router 2. So this is actually inbound. Yeah, tunnel 0, which is our interface, right? So I think that's what we have to do. So let's go ahead and do some configuration here. And first we have to disable this link like it told us, or we're going to have issues. Router 5 is considering. There he is. Hello, router 5. So what we're going to do, let's collapse this so everybody can see, and we're going to shut down this interface. And we should see neighbor adjacency lost. Yep. And we should now have one neighbor. And before we do anything, of course, we always want to just confirm that we actually need to make the change, that we're actually receiving show IP route EIGRP topology, actually show IP EIGRP topology. And let's just pick one of these, 150.1.1.1. Do I have that right? Show IP route. What did I type incorrectly? Oh, I have to use a mask. Yeah, so I've got many many successors here. In fact, well, I'm getting it from multiple routers, right? Now this is interesting, just kind of getting off a side note here. I'm looking at router 1. So really router 1 it should be the closest, and he is. In fact, in our routing table, it's coming from router 1, which we would expect. But we also have these candidate routes here from router 3, and the feasibility condition is met. We have really high numbers on a tunnel interface. Probably noticed that before. And that's because for a tunnel interface, your delay is big. They jack up the delay, which is appropriate. So I'm getting this from all these routers. So basically, I don't even want to see these in the topology table, right? As valid routes. So that's what we need to take away, and that is what I feel like we can do with this. I almost feel like I want to plug in part of this first. I feel like I want to do this in stages. Let's do that just for one, to get a little reacquainted with adding lines to an extended access list, right? So let's go ahead and create our access list first. Access list extended, or, well, there's two ways to do this, right? I could do a number, which I have, and then we're going to say deny host 150.1.4.4. See, I'm using a host statement because that's a /32. I could do that as well. I could do network 151.4.4 and 0.0.0.0. And then, of course, deny. Well, let's see here. Deny. Can I not do that? Oh, because I have to put an IP protocol number. Okay, I'm trying to remember. Do I have to say? Okay, we're just going to say IP. Yeah, host. Okay, that's what I was missing. It's interesting though that I have an EIGRP option here. What is the difference there? When I use a distribute list, I don't think I have to do that. That's a subject for later research. I'm going to put that on in my bucket list, my ever-growing bucket list of, yeah, look this stuff up and try to figure out what they're talking about. Access list 101 deny EIGRP. Yeah, well, let's just take a quick gander here. This would be protocol independent routing. IP routing protocol independent configuration guide. And we should have, well, I think we need the command here. Yeah, master index. Access list. Access list, IP extended, that's security. I don't want to look at the security book, not yet. All right, never mind. We'll look that up off stream. But for now, I think all I have to do here is deny IP host 150.1.4.4. Let's start with 1. And then 1.5.1.0.1. So, of course, when we're doing a distribute list, normally it's source and, normally you think of an access list as source and destination. But when you're using access list for a distribute list, in conjunction with a distribute list, it's source and router or gateway, right? So, yeah, we're going to try with this one and then complete. Oh, destination wildcard bits. Host. I can do host here too. 5.1.0.1. Yeah, I think that's what I want to do. And then I do access list 101 permit any. Permit IP any. So do show run access list 101. Show run begin access list. Deny IP host and permit IP any. Okay. And if we want, we can do show access list 101. This is where we should get our line numbers. Yeah. So we're going to play with that later and see how we can insert a line. All right, and then let's go to router EIGRP 100, distribute list 101, right? Because our options here are IP access list number. Now this is interesting. So this says IP access list number. This is IP expanded access list number or an access list name. My instructions are to use an extended access list, which I understand that is what I'm doing. Because if I go back, I think this is just nomenclature, but I find it interesting that, what is an expanded access list? And this is started at number 1300. Yeah, what is a expanded access list number? Inquiring minds want to know. We're not going to find out right now, though. I think I meet just the fact that I can add a destination means that I'm using an extended access list. So we're meeting our requirements of the lab. We're going to say distribute list. Oh, router. Yeah, EIGRP 100. Distribute list. And of course, we do this. We can do a name, gateway, prefix, and route map. All right, so in this case, we're going to say 101. And that is going to be in. And of course, we can do T0 for tunnel interface. Can we do anything other than that? No. All right. Let's do clear IP EIGRP neighbor. Just to reset. Now, show IP. Yep, new adjacency. Good. Show IP EIGRP topology 150.1.1.1/32. Okay, did not work. It could be that I'm using the wrong 155.1.0 originating router. Okay, who did I say I wanted to block it from? Okay, I said I wanted to block it from 155.1.0.1. I don't think that's, yeah, I'm supposed to do that. However, it looks like it blocked it from no one. 1, 2, 3, 4. Okay. So good thing we didn't type all that out. 155.1.0.2. Looks like this may be wrong. Let's see. Show IP EIGRP neighbor. That is the neighbor address. Okay, I've got them backwards. I have them backwards. So the format is access list extended. Or I can just put 101 here, right? Because that is, I think that's what I did. Deny IP host, and then we put the source, which this makes sense if we think about it. Because you're looking at routing prefixes. So it makes more sense that the source is actually going to be the sending router IP, whereas the destination is the prefix. I guess that makes sense. You can probably interpret it either way, but we need to do deny IP host 155.1.0.1 and then host 150.1.1.1. So let's try that. And what we're going to do here, if we're clever enough, show IP access list 101. All right, so typically, right, you think, okay, I have to remove all my lines, add them back. Well, let's see, access list 101. We can't really do that here, can we? No, that's just on the ASA. Or maybe I'm thinking of something else, but so let's just do this. No access list 101. Clear IP EIGRP neighbors. What I expect, I'm just thinking in my mind here out loud, which I do this whole time, right? But I have a distribute list still defined, 101 in tunnel 0. If I remove the access list, how does the processor interpret that, the routing process? Does it say, okay, distribute list this into tunnel 0? I don't have this, so I'm going to ignore it and just run normally? Or am I going to shut it down? Let's see. Show IP EIGRP route. Show, sorry, IP route EIGRP. Yeah, okay, it says, all right, you're an idiot. So we're just going to ignore the distribute list statement altogether. Good, that's, I guess, what we would want. So let's go back and create our access list. Access list. Just looking at this here. Man, there are a lot of different kinds of access lists. Maybe this is a clue as to what expanded is. Boy, MPLS, we're going to learn a lot because so we have IP standard is 1 through 99. 100 199 is IP extended access list. 1100 to 1199 extended 48-bit MAC address access list. IP standard access list expanded range. I'll bet that, I wonder if this has to do with like protocol labels. I don't know. 200 through 299 protocol type code access list. Never heard of it. 2000 to 2699 IP extended access list, expanded range. 2700 2799 MPLS access list. 300 to 399 DECnet access list. Thank goodness we don't have to do anything with that I know of. 700 through 799 48-bit MAC address access list. Compiled. I could see this, I am speculating here, but I could see that being necessary if you have really long access lists. You might want to compile them. Dynamic extended, extend the dynamic ACL absolute timer. Maybe that's when you have time windows. Rate limit, simple rate limit specific access list. Okay. Wow, I don't remember seeing this many access lists, but this is, newer code. I'm going to take a screenshot of that. All right, so getting back to our subject here, access list 101, deny IP host, and this is the router 101, and this is the route. Access list 101 permit any. Permit IP any. It's interesting too because when you look at access list 101 like we did earlier, got all these different types of access lists, extended access list parameters. So I can understand you have protocols other than IP, but of course EIGRP is an IP protocol. Encapsulation Security Payload, GRE, ICMP, IGMP, IP and IP tunneling, and you have KA9Q NOS compatible IP over IP tunneling. Let's memorize those parameters right away. OSPF, PCP, I forget what that is, but I have studied that, or I have read about it. I think that's a layer 2 mechanism for point-to-point tunneling protocol or something like that, where you want compression. PIM, that's multicast stuff. Stream control transmission protocol, TCP and UDP. Interesting. Okay, so we're going to do permit. We already updated our access list. So in our little experiment, let's do now show IP route EIGRP 150.1.1.1. Now let's do show IP EIGRP topology. Okay. So it looks like we are successfully blocking from router 1. So we've got our syntax down. Now we just need to update all these statements. So I'm going to do a quick, I'm going to do a find replace here. Use the power of the text editor. So we're going to say access list extended. We're going to place that with, actually just do extended 101 for 101. And then we want to replace deny host with deny IP host. And there's not really an easy way to swap these. A little busy work here. I could do, no, there's no duplication of combinations here. At least not one that my brain could easily work out in an efficient way. I need to put host here. Yeah, because this is router. That's right. Hope everyone's having a good Monday. Tuesday, sorry. Yeah, this is a good example of, I kind of built this beforehand, but obviously if you can be accurate in the front end on the real lab exam, I could see these are the kind of things that could be frustrating when the clock is ticking down and you're worried about your time. Of course, Notepad is going to make it a lot faster than having to redo a lot of this at the command line, for sure. And you don't want to get one little component wrong or one number incorrect. All right, so I think we have our, now I kind of went out of order here. Because I was trying to do 4 and 6 first, right? So the 4 and 6, 4, 6, 4, 6, and then we got 1, 2, 1, 2, 1, 2, 7, 7, 7, 9, 9, 9. That's right. And then permit any. Okay, so we're going to take out our access list. No access list 101. I'm going to paste this bad boy in here. And clear neighbors. This is where the magic happens. So I'm going to scroll back up here. These are original requirements. And let's just take a look if we have the result we want. For example, show IP EIGRP topology. And router 4 and router 6's loopback should only be coming from router 2. So let's look at router 4's loopback, which is 150.1.4.4. Look at that. Only from router 2. Yay. 6.6 should only be coming from router 2. It is. 1.1 should only be coming from router 3, and it is. Just because we want to admire our own work and bask in the glory of proper configuration, we're going to check each of these. Router 7 coming from router 1. Yay. Router 9. Booyah. Sweet. And no other routes are affected. So we should have lots of other routes. EIGRP topology. Yeah, we get all these other routes coming across the tunnel. Just those loopbacks. Good deal. All right, we are filtering kings here. Well, let's see. We got another. I want to do a reload here. Router 5, and we'll move on to our next lab. Offset lists. So this is going to, and this I'm not completely sure about on my research. I did a little bit of research, but I remember doing this in RIP, so hopefully it's very similar. Using EIGRP filtering with an offset list. So on router 7, we want to create an offset list so that traffic destined for router 3's loopback 0 is sent out of interface to router 6, which is the long way, because if we look at our topology, we have router 7 and router 3. So if we want to get to router 3's loopback, boom, we got one hop. But we want to manipulate the traffic using the offset list so that instead of going this way, that we're going to hop through router 6. Basically router 6, 1, and 3. So we're going to do 1, 2, 3 hops instead of 1. And additionally, if a link goes down, traffic is going to be rerouted directly to router 3. Now that seems obvious that would work. But I think the point of this is that we have to, I think it's a very important point, because I think what they're asking is, we don't want to manipulate this. Basically, we're going to have to manipulate this link. We're going to have to make this link to router 7 look much less attractive. So we're going to have to add a bunch of delay here. Say, you may think this is a gig link, but we want you to pretend like this is a dial-up link or something. The danger in that is obviously we want to transition. If this link goes down, first of all, we want this thing to be able to begin to route traffic this way. We don't want to make it so bad that router 7 refuses to send to router 3 at all over this link. And we would like for this route to still be unattractive, but not so much that it's not a feasible successor. We want this to be the successor route, but we want this to be a feasible successor route. So it should still be in the topology, and it should still satisfy the feasibility condition. So I'm going to shoot for a low number here. I'm going to try to make this higher than this, but still low enough to be, maybe I'm overcomplicating it, I don't know. But if we do that, that would, for me, from a design perspective, that would be much better. Because we want immediate, for whatever loco reason that we're saying we got to go this way instead of that, we want, if this link fails, we want this to transition immediately to router to this link, is what I'm thinking is behind this. So we're going to have to do a little bit of math here. I think that's going to be important. So for example, first of all, we want to see what is the metric, especially the feasibility metric for this route right now. So we're going to have to look at router 7 and say show IP EIGRP topology 150.1.3.3 /32. Keep forgetting to do that. So yeah, I have 1 in the table because obviously the other links are going to be much less attractive than this one, and they're not going to satisfy this feasibility condition. So the reported, this is our metric here. 130.816 or 128.256. All right, and I think the total delay 5010 microseconds. Again, when we're manipulating the offset list, we're going to be manipulating the delay. So that's what we want to kind of use to see if we can manipulate. So let's look, for example, at router 6. Let's look at his delay to that loopback address. Show IP EIGRP topology. 150.1.6.6/32. Oh, not 6.6. Interesting. When you do that, I should have did 3.3 here, but when you do 6.6 to it connected, in the topology table, it says descriptor block is 0.0.0.0. Very interesting. The things you find at the CLI. All right, yeah, he has 2 routes because he's getting it from router 7 as well. $50.20. So really this distance is going to change. Yeah, notice 130.816. The reported distance 130.816, and it adds. So we're kind of seeing the cost of an additional hop. It's basically 10 microseconds. So I'm thinking what we want to do is we want to, right now this is going to be 10, 20, 30. So this is going to be 50, second. On router 6, it is 5020. 5010 says 5010, 5020, 5030, as opposed to 5010. So if we make this 5040, that's probably the minimum that we have to add to make this route more attractive and allow him to still be a feasible successor. That's my theory. So if we add, what did I say, 20? 10, 50, 20, well, 50, 10, 50, 20, 50, 30, 10. So if I add 30 to this interface, well, not to the interface, but to this route on this interface, I think we'll be good. So that's going to be my X here. I put X here, 30 microseconds. So let's just see what that does. What is the metric for R3's L0? We saw that. How much delay to add to the interface? I think we figured that out, 30. So first, for our offset list, we have to use an access list, right? Because we're not adding delay to the interface for all the routes, just a single route. Now this is something that I could not find in the documentation in the command reference. I went to the command reference for this and it said offset list. Well, maybe I did. Sorry, that's the next one. That's administrative distance. The distance command I did not find all the options for in the Cisco documentation. We'll rant about that some more in a minute. But let's go back to router 7 because this is where we're going to manipulate the traffic, and we're going to create our access list. Access list 10, permit, and we're going to use host here because it's a /32 route in this case. So the host command works, the host option. And then we're going to go router EIGRP 100, offset list. Yeah, so we can use regular access list. This is interesting. Access list of networks to apply offset 0 selects all networks. So I have a little shortcut here. Instead of doing access list 0000/0, or yeah, 0, 0, 0, 0. I can do just access offset list 0 for all networks. That's kind of cool. Good to know. I wonder if that's the default behavior anyway. If 0 would be kind of unnecessary. I think it would be. And then access list of networks to apply offset extended range. Again, we have not expanded, but extended range. And then an access list name, which would be an extended access list, right? We're going to do offset list 10. And that is going to be, this is a route that is learned inbound on GI 0137. Oh, I have to put the offset here. So offset is going to be 30. And then my interface, GI 0137. Interesting enough, if I left the interface off, that would be for all routes in, all interfaces. Not all routes, it'd be routes in access list 10, but in all interfaces. We don't want to do that. That would poison the other link, right? The other route that we want it to take. Okay, so it took the command, and if we do show IP protocols, I think that's where we will see, we can validate. Yep, incoming routes in GI 0137 will have 30 added to metric if on list 10. I love how that's very succinct. Okay, then we get the neighbor route configuration changed from, so we expect that. All right, so now we need to first let us check the metric. Well, let's just go and check the routing table first. Show IP route 150.1.3.3. Excuse me there. Okay, I have 6.6 here. That would be a typo. Did I do that wrong? Show access list 10. Yeah, that's a typo. No access list 10. Access list 10. Permit host 150.1.3.3. We should get a reset here. If not, I'll reset it myself. No, there we go. Okay, so now show IP route 150.1.3.3. Okay, it is still getting it from router 3. Let's look at the metric then. 130.846. Show IP EIGRP topology 150.1.3.3 /32. I keep forgetting that. Show IP EIGRP topology. Okay, now at least I have the other, I have two routes in the table, but the metric is not exactly right where we want it. All right, notice that, oh, you know why? Look at that, 5011. Previously it was 5010. We need to scale up our microseconds. This is, I was saying tens of microseconds. But when you use that in the offset list, that is just 10 microseconds. Or it scales it down, it looks like. Yeah. So it scaled that down to 1. Huh. Interesting. Do we see that in the documentation? No, probably not. Let's look at offset Now I have to go down to O. Offset list EIGRP. Yeah, see, this does say, okay, you can use an access list number or name in offset. And positive offset to be applied to metrics for networks. If the offset is 0, no action is taken. It doesn't really give me yeah, there are no details here, people. So you just have to do a little guessing till you can figure out what they're talking about, I guess. Well, we can see right there what it's doing. So we obviously need to change this to 100, right? Or no, what I say, 300. I think. Or is it saying this is the offset? No, that's the access list. Yeah, I think I need to scale it up to 300. Interesting though, we did at least, we can see the impact when we increased it. It added 1 microsecond to this delay. That was enough to make this a feasible successor, because this is now, let's see here. Topology entry for 1, status passive, query origin successor, 130816. Feasible distance. Now this is still higher than that. $131072 is still higher than this number. So why is that? How is that a feasible successor in the table? Doesn't seem right. Total delay 5011, total delay 5030. Obviously, if we bump that up, we get this number to 5040. That's what we want. But I'm curious as how this is even considered. All right, show IP route 150.1.3.3. Metric is 130846. Now see, this is total delay is 5012. Okay. All right, show IP EIGRP topology 50.1.3.3/32. Yeah, I'm not sure how that is even being considered. Well, let's continue along. I'll look that up at some point. Take a screenshot of that. Because I thought I understood how that worked, and now it's making me doubt myself. So let's put this back. All right, router, EIGRP 100, no offset list 10 in J0 37 30. In GI0 137. Okay, yeah, we don't have to put the offset in the no command. Offset list 10 in. Okay, yeah, this is where we put. So this is in 300. Yeah, see, all it says here is offset. It has no indication of what that offset number represents. Okay, now we did 300. So we should see the routing process clear. Resync. Show IP route 1.1.3.3. It is still coming from, okay. So my metric went up by 11. So I guess we're not accounting for the scale because we have to scale both the bandwidth. It's scaling both the bandwidth and the microseconds, so which makes sense. So we can continue to do this by experimentation. I guess we want. Let me just look at the topology again. EIGRP topology. Yeah, they're both still in here. 131072. Now this is less than that. So I could definitely understand now why this is a feasible successor. We're getting closer, actually. Delay is 5030, delay is 5021. The metric is 131328. Wow, we're very close on this metric. So I'm just going to, this is not going to significantly impact. I'm going to put 2000 on here. We're going to get wild and crazy. Router EIGRP 100. No offset. We're going to blow this mother. 0137. Blow it out of the water here. All right, now we really cranked it up. All right, this is still higher than that one. Oh, it hadn't cleared yet. Got impatient, Quentin. Yeah, now this route is preferred. I noticed it seems to put these in order. I wonder what order it decides to do these, like when you have 5 equal cost routes. Is that a random order? Questions we're not going to concern ourselves with at the moment. So 131, yeah, and this is still a feasible successor. So 6 is now more attractive. 5030 microseconds, which has remained constant. And this is now 5088. It is still a feasible successor, but his metric is now higher than the route to router 6, through router 6. So through the process of throwing some darts at the bullseye, we have come up with a solution here. Let's do a trace route. 150.1.3.3. Yeah, it's taking the long route like we want. Now, one thing we also need to validate is that we only impacted this loopback 0. We should not have impacted other routes coming through router 3. So when I do show IP route EIGRP, I should see a lot more coming from router 3, like router 2's loop back, right? So router 5, router 6, router 4. Now, should that be coming through? Yeah, because 1, 2 hops. Router 5 should probably be coming that way. Anything that, although we disabled this interface, not for this exercise, we didn't. So yeah, this is going to be faster always because of the high delay on a DMVPN tunnel. Now router 2's loop back, he should still come through router 3, and I think he does. Yeah, he's coming through router 3. Same with router 1. Yeah, got equal cost routing going on there. So yeah, we've accomplished what we want so far. Now we have to check the impasture goes, and we have to validate if the interface goes down. So let's run a ping from router 3. We're going to bring the interface down. So let's do ping. Well, no, let's do it from router 7. Yeah, let's do it from router 7 and bring the interface down on router 6 upstream. So it's ping 150.1.3.3. Repeat a whole bunch of times. Let's go here to router 6. And shut down this interface for J0167. Shut. So I would not expect to lose that many pings. Yeah, something went wrong. Maybe not. Okay, that's because the hold down time expired. So did it query? I don't think that's what we wanted. Show IP route EIGRP 150.1.3.3. /32. It still has the same. Okay, I think that's as fast as we're going to get probably here in viral. That's decently quick. We lost one. Let's see, 1, 2, 3, 4, 5, 6, 7. So the interface went down, and then I'd seriously doubt it sent query packets because it already had a route in the routing table. We saw that. So, all right, I think we're good there. So let's just reboot. Let's reload these routers. I think we're good on this lab, folks. Save no, reload. And we'll reboot those guys. So that's good. I would like to, there were a few caveats there that I did not quite understand. Granted, I could have done some math here to figure out using the bandwidth and the delay the exact number that we want, but in real life, I mean, especially since we're going to have limited time on the lab, I think as long as we get that result, I'm feeling okay with that. Unless it said, you know, if the lab were to say use the lowest possible delay adjustment to get this accomplished, then yes. But if it doesn't, I think we're fine there. So moving right along, we're gonna head into the third lab, which is EIGRP filtering with administrative distance. We've done a lot of these in RIP already. I did not remember how to do this when I was researching earlier. And what really threw me off is I don't remember what really threw me off. I think I was looking at one of the configuration guides, but I eventually found it. It's this distance command. And of course, we're wanting to do if it says we don't want to install this route in the routing table, when using administrative distance, automatically know that means 255 unreachable. We want to give a particular route an administrative distance of 255. And we can do that with an access list. So let's look at our requirements. On router 6, configure administrative distance so that router 4's loopback 0 prefix is not installed. So if we look at router 6, I don't even think that topology is important here, really. We know that he's a neighbor, but we just want to poison that. We want to poison that route, basically. I call it poison. There are probably other ways to call it, but poison's more fun. So we use an access list to specify our route. We'll wait for okay, router 6 is now up. He should have this route already. I've got to get used to when to use, if I want to see a /32 route here, I've got to use the mask, right? If I want to do show IP route EIGRP, 150.1.4.4, then I have to filter, include, right, or begin. Show IP EIGRP topology, I have to do a /32. I have to specify the mask. Now, can I do this? Yeah, I can do a mask. Or I can do /32. But I have to remember to do that. 32 takes less time, right? All right, so I have this route. So I'm going to do an access list. We're going to do permit host. And we do host because this is a /32 route. It's a loopback, right? And then we're going to say router EIGRP 100 distance command. 255 and IP source address. I don't. Yeah, this is what confused me here because, like here it says put the IP source address. However, which we could do. But in the documentation, somewhere I found you can use an access list here. So, set route. Yeah, I saw I can do EIGRP here, and that is for the process itself. For internal or external routes, I could change the default behavior, right? Of course, I don't want to do that. I think it's 90 and 170. 90 for internal, 170 for external. I could change that here. But as is noted in the guide, this could be dangerous because the EIGRP protocol depends on neighbors kind of agreeing on what the parameters are of the network. You know, you have to kind of agree on the rules, what the rules are going to be when we're advertising these updates to each other. If we change that, that could have, especially downstream or farther upstream, it could have a negative impact on our routing behavior. But for a single route, and obviously this being the last filtering exercise that we're doing, this is probably the least preferred way to do this, which I also read they would probably love to throw at us in the lab exam. However, we don't want to use that. So when I looked up distance, I saw somewhere where I could use an access list here. That's why I have created an access list. Geez, maybe not. So I'm assuming source address, is that going to be the router? Let's see, let's just put the router address in here. That would be, where would I be learning that route from in case that's what it's asking? 151.44? Let's see. Do show IP route. One 146.4. Distance 255. Wildcard bits. Okay. So I have to put a source first before I can use an access list. Interesting. But see, I don't want that prefix installed from anywhere. So maybe I have to do, yeah, I have to do 0000 here as the source. So any source, right? All right, let's see. Show IP route 150.1.4.4. Wait, peer restarted. Yeah, see. I'm no longer learning it from router 4. By gosh, I'm still learning it from someone else. So yeah, I think that's what we need to do. It is going to make us put a source. So I'm going to say no distance. No, no chance there. Do show run. Gonna make me take the whole thing out. All right, distance 255 and 0.0.0.0. So any. And it's going to be 10. Yeah, I used the wrong mask there, didn't I? Distance. Pretty sure I did. Show IP route 150.1.4.4. Okay, so what happened here? I'm still learning it. So by using the wrong mask, what it's saying is only block from router 0.0.0.0. Literally. So that's not going to work because we're not learning any of those updates from him, right? From a router with the address of 0.0.0. Need distance 0.0.0.0, 205, 205, 205, 255, 10. All right. That should do it. Show IP route. All right, let's wait for reset here. And neighbor change. Now, boom, gone. Okay, so let's, you know what would be interesting? Still resetting. So does that mean that even though it's not in the routing and the forwarding information base, is it still in the topology table? Nope, it's not. It's definitely poison. So it's like, goodbye. Am I still learning other routes from router 4? I am. Yeah, I'm learning plenty of routes from router 4. Okay, that does it. We may just make a flashcard for that, which is distance to 5, 0.0.0.0. Yep. Just before I close out, that's the last lab I had prepared. Let me see what's coming up next. I think we're getting into per neighbor administrative distance, and then there is EIGRP filtering with route maps. Oh, we might do another one or two. Yeah, let's throw this one in here. I haven't researched this yet, but hey, let's wing it. I think I've done this before. I think we did this with, I think there's just going to be a variation of the distance command where we're specifying a particular, this is in a wildcard, right? We don't want that route from any router. But I think this is going to be a variation. Let's see here. Our requirements are, this is per neighbor. Give ourselves some room because I know my head's right there. Stream. Per neighbor AD. Configure AD on router 3. So that R7's L0 sent to router 1. So let's let that soak in for a second. And R3 never uses direct path via R7. Never. Okay, well, let's try to unpack this first. Configure per neighbor administrative distance on router 3. Okay, router 3 and router 7 are neighbors. All right, so we're saying that at least for the loopback 0 of router 7, we want this to go through router 1. We want it to go the long way home. Not only that, but we want router 3 to never use a direct path via router 7. What that tells me is all routes. All routing updates from this neighbor need to have a higher administrative distance than this neighbor. And this is the kind of more direct, a couple things I liked about this. This kind of overrides, administrative distance kind of overrides any routing metrics, right? It's kind of the major overriding factor. The higher priority over versus even for other routing protocols, right? We can manipulate. Let's say we had BGP, for example. eBGP route is going to be administrative distance of 20. I guess I could theoretically make an EIGRP route. I could give it precedence over a BGP route because of the administrative distance. I can make it 10. So that's one advantage of doing this. The other is that it's locally significant, right? It's only going to impact. It will impact routes traversing through me, but this AD setting is only locally significant. It's not going to somehow affect the metrics used on other routers. So I actually see some advantages to manipulating AD. All right. So I think what we're going to do, we're going to go back to our handy dandy distance command. I think all we're really going to do here we can leave off a networks, and I would assume all. So right now, if we look at router 3, do we need to reboot anybody? What do we change? We changed router 6. Let's just reload him. So if we look at router 3, show IP route. We're going to use as our benchmark router 7's loopback 150.1.7.7. So distance is 90, right? That's the default internal EIGRP routing administrative distance. That comes first, distance, then metric. So what if we changed it to 100? So what we would do is something like this: router EIGRP 100, distanced 100. And it's going to be the source. Now router 3 only has it's only going to get updates. It only has one link to router 7. So it would always be this address. That would be the wildcard mask. I want to observe all bits. And I think we can leave that blank. This sounds easy, but I think that's all we have to do. Well, of course it's easy because we just did a distance. Just did a distance lab, so of course it's easy in this context. But let's try that. I think router 6, as it restarted, still booting up. We can still do the command though. Router EIGRP 100. Let's just check our distance command parameters and make sure. So distance we're going to say is 100. 1.5.1.37.7, 0.0.0.0. And we can just hit enter here. So that would be any update from that guy. All right, let's make sure he's coming up. Let's make sure he has a route, show IP. Yeah. Yeah, in the context of an actual lab where we've got 100 different problems, remembering this specific configuration, of course, it'll be a lot different. But we'll probably practice this lab a few more times before it's over and done with. All right, router 3, adjacency's up. Show IP route 150.1.7.7. Our distance is 100. Okay, it just updated it. Took it a second. But now he is going through 155.113.101, so router 1. Yep. Even though when you look at this, right, this has a lower metric. Doesn't matter. We go by distance first before we even look at metrics. So that's what we want. Let's look at the rest of our routing table. Yeah, we're not getting any routes anymore from router 7. Now, let's say our link goes down, right? To well, let me look at this. Is it in the topology table? Okay. Yeah, we got a lot of routes to it in the topology table. We have a route through router 1, router 5 over the tunnel. And that's interesting. So you could look here in you can't just go by the topology table, right? First of all, topology table does not show you the administrative distance that I can see. I'm scanning here. I don't see yeah, because if we look here, our lowest feasible distance, or our lowest composite metric is this route, but he's listed last because he's not the route being used. 131.328. This is lower than that, but sorry, buddy, you're at the back of the line. So if we were to theoretically take down these other interfaces, yes, he would use this route. He would fail over to it. Cool stuff. All right, let me check the key. Did I do that right? Now, there's a pitfall here. Administrative distance for EIGRP internal routes can be changed on a per prefix basis, but external EIGRP routes cannot. Okay, good to know. Now this poisoned the route. Oh, because, oh, look at this. R3 never uses the direct path. So even if we don't want to go there under any circumstances. So in that case, we should have done 255. And they wanted us to use, I guess, the wording. When it says here R3 never used a direct path via R7, this is kind of a bullet underneath this. So what it's wanting me to do is actually still use an access list here. This is still just talking about this route. So we'll make it right. I will say no distance 245. We got the concept right though. Let's do access list 9 or 7. Permit host 150.1.7.7. And then we're going to say router EIGRP 100, distance 255, and access list 7. I just misunderstood what it wanted. I knew how to do it. I just misinterpreted the requirement. Adjacencies reset. Show IP route 1.7.7. Yeah, so it's still coming through router 1. Do the trace route. Yep, goes through router 6. And I should still now have routes through router 7. Yeah, I still have other loopbacks. Easy enough. Cool, we got through that one. Okay, this one's a little more in depth. This is route map. We're starting to hit the route map section. As a matter of fact, the next set of labs, all right, we did extended access list, offset list, administrative distance, per neighbor administrative distance. Oh, really moving through EIGRP. Am I just not being thorough enough, or I don't know, but we're flying. The next one is with route maps. And then there are, let's see, 1, 2, 3, 4, 5. There's just 6 left. EIGRP. I'm thinking that what I'm going to do is probably the next 2-3 days, finish these 6 labs. I should be able to finish these 6 in the next 2 days. And then that'll take me to Thursday. And then Friday, I'm going to do a review. I'm going to do wrap-up review. And then come back through and probably repeat some of these that gave me trouble. And then review some material for EIGRP, maybe even some videos. But that about wraps it up for tonight. Thanks for joining. Appreciate the viewers here. And again, feel free anytime to chat, but feel free to lurk too. Do whatever you want. Watch the videos later. You might be watching this video offline. Thanks for joining. Happy labbing, happy studying, and we'll see you tomorrow night.